Hello, and welcome to today's Tech Talk on route optimization for food, beverage, and less-than-truckload or LTL delivery. My name is Haley. I'm part of the marketing team here at NextMove, and I will be your MC today. Today's presenter is Daniel Mueller, Solutions Engineer at NextMove, and he'll be covering a lot of ground today in our 30-minute session. First, he'll be starting with a brief overview to set the stage for today's talk before diving into a live demo where he's going to show you how to build out a custom decision model that's applicable to this space, deploy it into a remote environment, and demonstrate some of our latest experimentation features, which I'm particularly excited about. We're going to save some time at the end for Q&A, so don't hesitate to drop your questions either into the chat feature. Just remember to keep an eye on that host and panelist versus everyone toggle, just so your message goes to the right group. Or feel free to use the Q&A feature at any time during the presentation. I'll make sure to resurface them at the end. So with that, I'm going to step into the background, and Daniel, let you take it away.
Yeah, thank you, Haley, and hello, everybody. As Haley mentioned, we want to show a lot of things today in our tech talk. And before we do that, let's take a quick look at what kind of optimization problem we're looking at today. And as the title already told you, we're looking at food and beverage transportation, LTL transportation, and also restaurant deliveries. They have some common properties, but also some distinguishing properties. And I want to give you a brief overview of those. So, for example, for restaurants, of course, we're looking at ordered meals that have to be transported from restaurants to the customer's home. So we have a pickup stop at the restaurant, drop-off stop at the house of the customer. And similar for food and beverage deliveries, we have some place where we want to pick up our items. This might be a farm, it could be a factory or a warehouse, and we want to transport those to some drop-off location, like a warehouse, a store. And same goes for LTL transportation, where we are going to pick up maybe an item at a depot or at a warehouse, and we're transporting that to some store or also to a customer's house. Of course, the items that are transported are very different. So restaurant orders are usually some meals for lunch, dinner, something like this. There might be pizza, steak dinners. Food and beverage transportation, of course, has a slightly larger scale. So we are looking at maybe some wine crates, larger quantities of onions, for example, that need to be transported. And LTL transportation can be something completely different. So maybe we have also some packaged food that needs to be transported, but it could also be clothing, furniture, and so on. And all of these businesses, of course, need some vehicles for the transportation. And those businesses have, due to their different scale, different vehicle types that are relevant for those businesses. So, for example, a restaurant delivery could be transported by a bike, as it might be just like one order or two orders on the bike that gets assigned, and the distances that need to be traveled are very small. This could be totally different for food and beverage deliveries and LTL transportation, as distances between warehouses and stores or depots and stores might be larger, and also the scale of the items and the quantity of the items could be larger and probably won't fit on a single bike here. The cadence of these transportation problems is very similar for all of these businesses, or could be very similar. So for all of these businesses, we might have some kind of a real-time scenario, which means that we get an order, and as soon as we get this order, we want to replan, we want to reoptimize our plan, so that we can assign the order to one of our vehicles or drivers. But there could also be some planned scenario where we have some knowledge of the orders, for example, for the next day or some time ahead. And we are going to plan the next day, the evening before, for example, and prepare the plans for our vehicles so that they can start early in the morning the next day. It could also be a mixture of both. So let's say that we know a couple of orders in advance. We're planning in the evening for the next day, but during the next day, there will be some orders coming in, and we might want to check in real time whether we can fit this order in on that day, or whether we need to move this order maybe to the next day. So that's something that might also appear in these businesses. And the common denominator here for these different business types is the question, how do I deliver bundles of pickups and drop-offs in the most efficient way, and how do I assign those to my vehicles? And that's something that we are going to solve today with our live demo, with the model we're building in the live demo. And before we jump into that, let's consider a couple of common constraints in this problem. So, for example, capacity, as I already mentioned, is something very important here in this transportation problem. Bikes have different capacities as trucks, for example, and that determines, of course, how many items and how many orders I can put on a single vehicle for its route. Also, we might have different driver shifts, meaning that drivers might start early in the morning or they might start in the afternoon. And that, of course, also determines maybe which stops they can serve and their route in the end. Vehicles and drivers have start and end locations. We might have some time windows that we need to consider here in our solution. So, for example, when we want to pick up something from a warehouse, the warehouse might give us a time window that we need to consider, that we need to reach for this item. And if we are late for that or early for this time window, we either have to wait until the time window opens, or if we are late, maybe we have to wait for a new time window the warehouse can offer us, and that, of course, might give us some delay on our operation there. And we also have some compatibility attributes here. So, for example, food might need to be refrigerated on the vehicles. And not every vehicle might offer this option. So that's something to consider here. And we also might have some commingling specifications. So maybe food is not, it's not possible to transport food on the same vehicle as some chemicals, for example. And we also want to consider that in our solution in the end. We can have some penalties in our model as well. So, for example, we want to avoid unassigned deliveries, and that's what we want to penalize in our model. And also, each stop might have a different stop duration, a different service time. As you can imagine, delivering a single pallet or packing a single pallet on the truck takes a different amount of time than packing 5 pallets of something. So that's something that we can also consider in the model. And backlogs is something for the scenario where we are replanning our optimization problem. As I mentioned before, we get maybe a new order during the day, and we want to re-optimize our plan to see whether we can fit this order in. But we still want to keep the original plan somehow fixed. So the assignment of orders to our vehicles should stay the same, and for that we can use backlogs in our model. And finally, we might have a different vehicle types in our fleet, and each vehicle type is associated with some initialization costs here, so that the solver can decide which vehicle is the best fit for our problem. Yeah, and of course, we might have some optimization objectives that we want to consider in the model that we are trying to optimize for. This could be, for example, minimizing time on road for vehicles. It could also be something like maximizing the fleet utilization or minimizing distance. It could also be something more general, like minimizing costs or maximizing profits, or something completely different, minimizing greenhouse gas emissions, for example. It's also possible that you might have some specific quality goals that you want to optimize for. That could also be implemented in a custom value function. And of course, it could also be a mixture of these objectives coming together to build a single objective function here for the model. So before we jump into the live demo, let me quickly give you an overview of what the problem setup looks like today. So the objective of the model, as I mentioned before, is picking up and dropping off all bundles of goods at designated stops in the shortest amount of time, while meeting all constraints. And our input consists of a set of vehicles. And in this case, I prepared a sample with 6 vehicles. We have 30 orders in this sample input, and each order has a single pickup and drop-off stop. So we have a total number of 60 stops in the end. Our vehicles have capacities. We have some time windows that we need to consider here for our stops. We have a single compatibility attribute here right now in this model or in the sample data. This is refrigeration. So there are some vehicles offering a refrigerated compartment, and we have some stops that need this attribute to be transported. So that should be considered by the model. And also we want to use unassigned penalties just to make sure that we assign as many stops as possible to our solution. Yeah, and I will also show you how to customize the value function with a simple example and yeah, evaluating that and comparing it to the original model. So with that, let's quickly jump over to my dev environment. So you can see on my left side right now is my terminal, and my right side is my Visual Studio Code. And I already have the model open here right now. So this is based on our routing template that comes with our platform. And before I go into detail, let me quickly show you how you can set up this yourselves if you want to test it out on your machine. So if you go on our website, cloud.nextmv.io, you will see a screen like this, offering a couple of use cases. As I said, I based this model on the routing use case. So if you click on this button, you will get some steps that you can follow to install and configure our commander interface and also the SDK. And then there will be a step that tells you how to set up the routing template that gives you a nice start for working on your own model. So with that, let's quickly jump back. As I said, I set this up already. This is the model for this presentation based on the routing template. This already comes with a predefined input schema, so we don't have to do anything about that right now. And it also comes with a predefined model definition. So I removed a couple of constraints from the original template model just to make it a little bit simpler. And I thought that those constraints were not really relevant for today's session. But some constraints I left in this model, and those are the ones that you saw earlier on the slide. So, for example, we have here a definition of velocities for our vehicles. We give our vehicles and stops directly here at the start into our router engine that will solve this problem. Our vehicles are associated with starts and end locations. We have some capacity definition here for our vehicles and stops. We have a precedence option as well in this model, which defines the sequence of stops. So it tells the solver, for example, that a pickup stop has to happen before the drop-off stop of an order, so that that sequence is correct in the end in the solution. We have service times for each stop. Then we have shift definitions for our vehicles, time windows. Here are the penalties that I mentioned earlier, our initialization costs. We have the backlog option as well. So just in case you want to re-optimize and you want to keep the original plan in the backlog, that's the option you can use. And then we have the attribute here at the end, the attribute option, which is defined in two parts. One part is telling the solver which vehicle offers which attribute. And the second part is the information of which stop requires an attribute. And this will be then matched by the solver in the end for the solution. There's a second thing I want to show you, and this is the sample input I prepared for this talk. So as I mentioned, we have 6 vehicles here. Each vehicle has a certain velocity that is used to calculate ETAs and travel times. We have our list of stops. So each order has 2 stops, a pickup stop and a drop-off stop. Then we have our start and end location definition, capacities and quantities. Here is the shift definition for our vehicles. So in this example, we have 3 vehicles starting at 6 a.m. and ending their shift at 3 p.m. And then we have 3 vehicles starting their shift at 11 a.m. and ending at 8 p.m. So that's something that you can adjust in the input file here. And then at the end, we have the definition of our attributes. So we have 3 vehicles offering the attribute refrigerated. And then we have a list of stops that require this attribute so that the solver can match that up in the solution. Okay, so let's go back to the model once more. So let's assume we already worked on this model for some time. We tested it locally on our machine, and we are quite happy with what we're seeing. So one step that we want to take maybe is to make use of this model by deploying it. And the simple thing you can do is you can run some commands on our command line interface to deploy this model. The first one would be to create a new app, a new application for this model. We call it here LTL, just for this tech talk. And this creates a new application where you can then push your model that you created locally to. So by saying next move app push to this application, we will build a binary of this model that you see on the right side, and this will be uploaded into Nextmove Cloud, where it then will be hosted so that you can easily use it just like any other API. So you get some curl commands here, for example, and you also get a specific endpoint here. Let me quickly clear this up. By pushing this model, you created a development instance of this model. So this could be something where you just want to test it, maybe you want to test some integration with it. But then maybe you say a model is already running perfectly. I want to put it into a more production environment or more productive environment. And you can do this with Nextmove app promote. So this will take the current development instance and create a production instance from that. And similar as before, you will get a couple of information here. So you can run your app either via the CLI or with the curl command or with the endpoint directly. So that's something you can prepare. And just to show you how we can run a model here or run our input file with this model, let us quickly do that. So by calling Nextmove app run for this application and giving it the input that you just saw on the right side here, we can run this, and the flag default tells the CLI that we want to use our default production instance for that we just promoted. So let's see what's happening here. So we submitted this run, we get a run ID, and we can jump back to our console here and go to the apps section. And there you will see the app that we just created, LTL. By clicking on it, you will get some detailed information about this app, and you can also access the run history. And the run history now contains the run that we just submitted. So you can open this up, and you can also see the result of this run visualized on the right side with a small map with the routes. You will get information for all of the vehicles, the stops that have been assigned. You can also click on the icons on the map to get some more information about ETAs, but you can also access detailed information here in the output JSON that is also displayed here. So yeah, that already looks pretty good. Maybe one step you want to do next is you want to share this with your team. So maybe you have another colleague who's working on the model, or you want to get some feedback on the model. And that's what we're doing right now. So Haley, I would like to invite you to my team. So maybe you can check this model and give me some feedback. And for that, I'm going to invite her with our new team feature to my team. So I can invite a new member. I will just quickly add her to my team, send out an invite, and we'll just stop sharing my screen. So Haley, maybe you can take over the screen once more and show us what you're seeing on your side.
You bet. I always want to be on Daniel's team. Daniel's team is the best team. All right. Everybody should be able to see my screen now. I'm on the landing page here for the Nextmove console, but you can also see that I have a pending team invite. So before I accept, you can see here that within my team of Haley, I don't have any apps created, but if I did want to make one, you can see that there's a quick 5-minute starter guide to get up and running with that. But as I go to accept Daniel's invite, I now have access to get to his team. But as you see here in apps, I still don't have anything, but that's because I haven't switched just yet. So if I move over to Daniel's team here, you can now see that I can see his LTL application that he created. So if I were to click in here, I can go in and see the run history associated with the app that he just created as well. So I think this ends up becoming a really powerful tool, especially if this were a scenario in which I was an operator and I wanted to collaborate with Daniel on addressing feedback that we were potentially getting from the field. Either routes might be X or Z shaped according to some drivers, or say deliveries are getting assigned to drivers towards the end of their shift, or we've been getting feedback that some drivers are getting assigned more stops than potentially others, and we want to be able to balance out that vehicle utilization. This is a really cool opportunity for Daniel and I to have that conversation versus Daniel taking screenshots or verbally illustrating to the best of his ability what's going on in the model and what those results look like. So I think actually the vehicle utilization piece sets up the next piece that you'd like to show here, Daniel. So I'm going to hand it back to you.
Yeah, cool. Thank you. Let me quickly share again my screen here. Okay, yeah. So thank you, Heli, for that feedback. Let's assume we got some feedback from her, and we discussed what the model could look like in the future. Maybe some ideas for changing the model. And one of those ideas was a custom value function, as Heli mentioned. Maybe something about utilization of our fleet. And that's something that we want to build. So we want to build a custom value function, add it to our model. And of course, we want to compare this new model with our current running model. And for that, we have a different feature now available called experiments. So you can use batch experiments here to run experiments on historic input data. And that's exactly what we want to do right now. And for that, first of all, what I'm going to do is I'm going to create some historic input data by running a couple of input files with our app right now. So let me just quickly start those. And in the meantime, I can show you what I'm running right now. So I created a couple of more inputs here in this folder experiments, which is a variation of our original input. And I just submitted those as runs so that I can use them as an input set for our batch experiment. And I can also start with the next step, which is setting up the input set. So we have a new command in our CLI called experiment, which allows you for a couple of things. One of those is setting up creating a new input set. I call it past runs because I'm using one of the 4 runs I just did. So I tell also in which application I'm in. So it's still the application LTL, and also the current production instance I'm looking at. And I'm limiting this instance set on the last 4 runs or inputs that I used here. We will see those input IDs right now here, just to check them and make sure that this is correct. So we have our input set defined. And of course, I've been talking about creating custom value function. So we need to model that as well. And I already prepared a couple of code snippets for that. So let me just quickly copy this over into our model. The first part here is we need to define new structs here for our update functions. So we have a vehicle updater function, which we don't use in this example. And we have a plan updater function, which defines the new custom value function. And here we have a very simplified consideration of volume utilization in the value function. And the second part here that we need to add to our model is actually using those new functions and structs in our model. So we're going to add a new option here, which is called update. And we need to use those structs that we just defined. And this is already enough customization that we are going to do. So we can take this model and push it again to Nextmove Cloud. So we build a new binary here, which then gets uploaded to Nextmove Cloud. And then when this is uploaded, we can create a new version out of this binary that we just uploaded. So let me just clear the screen here once more. So we create a new version for the binary we just uploaded. I will call this version a new value function, just to have a good association here with what we did with this version. And then the next step before we start with our experiment is we need to create a new instance for this version. So we can only run instances here in Nextmove Cloud. And if you want to compare this binary, this version of the model with the current production version, we need to create an instance, which we also call new value function. And that's all we have to do. as a preparation for our experiments. And now we can create the batch experiment that I've been talking about before, also by using the experiment command. And there we have batch start as a subcommand, which allows for a batch experiment to start. We give it an ID, experiment 1, and a name, compare value functions. The input set has to be notified here or has to be set here. And we are using the past runs input set that we defined earlier. And these are the instance IDs that we're looking at. So I'm looking at LTL, which is the current production instance. And I'm looking at the new value function instance that we just created. And this will start a new batch experiment. You can see a small summary here. So we have 2 instances with 4 runs per instance, giving us a total number of runs of 8. That's exactly what we want to do. And you can see we submitted that. We get an experiment ID back, which is the same ID as we defined. And we can jump over back to our screen, back to the batch experiment screen, give it a little refresh here, and then we will see a summary of this experiment when we click on this one here. And the summary will give you some information about the instances you have been using, the runs on each instance. You get some statistics here, like mean values, elapsed time as a mean on all those runs. And at the bottom here, you will also see the list of experiment runs for each instance. And you can also click on those to jump into the detailed screen that you saw earlier when we looked at the solutions. Okay, so let's jump back to our presentation. I think that's for now the live demo. I think it was a great success. You saw a couple of things that are possible right now with the model. And before I close my talk here, some considerations for working with an optimization app in this area. So there might be some things you want to evaluate or change in such a model and test out, like modified shift times. For your drivers, maybe you want to limit the max route length for your vehicles. Maybe your fleet is even more diverse. So you have different vehicle velocities and so on. So there are a couple of things you might want to test out in some iterations here. And we often get the question, how often should you run your decision app? And that always depends on your business and your operations. So you can ask yourself the questions, when and how often do you pack your vehicles? What is your planning horizon like, and when and how often do orders come in? So again, real-time versus planned scenario here. Those are questions that you need to consider when determining how often you should run the app. And finally, some takeaways from this talk. So you saw that Nextmove offers a configurable routing optimization model with configurable constraints out of the box. You can customize your model to your requirements and build and deploy it in under 30 minutes, and even experiment with it and with different instances of your delivery model to start evaluating different iterations or versions. And as you also saw, you can share your decision app with your team for collaboration there. And with that, I'm giving it back to you, Haley, for Q&A time.
Your collaborator has returned. Yes, no, thank you, Daniel. That was a wonderful presentation. And I know that we're right up against the half hour here, but I do want to be able to slip in a question that we did get from the audience. And it probably split into 2 now that I look at it. But I think the question here that came in was, if there's a constraint that isn't represented by kind of the default options that are available in the routing template, is it possible to create your own? And I'll add on to that, generally, how long do you feel like that takes? Are we talking tens of minutes, hours? Do you have to take PTO? Yeah.
Yeah. So right, if you have some constraint that is not reflected by our standard default options, you can use another option which is called constraint. You can create a custom constraint inside of that, which then allows you for a more customized model, as you saw in this demo. So there's room for custom constraints as well. About the amount of time that goes into this model. So this template already gives you a great starting point. Setting up and removing a couple of constraints or options is very quickly done. So this is like a matter of minutes. And if you are starting to customize it, adding a custom value function or custom constraint, the first iteration is could also be quite fast. And then, of course, it depends on the actual business rule you want to implement or the actual KPI or metric you want to implement in your custom value function on how fast this can be done. But setting this up will be a matter of minutes.
Great. Great. One more question for you. I know on one of the previous slides, you had made some or highlighted some considerations about how frequently you might run your model. Can you speak to considerations around runtime for your model?
Yeah, sure. So, of course, runtime depends on your input size. So if you have more stops, more vehicles, of course, this will take a little bit longer for the solver to find a good solution compared to a smaller instance. We have seen many customers with input files that run in a matter of milliseconds that can be solved in a matter of milliseconds. But of course, there are also some examples that take a little bit longer. Usually it's a question of how much improvement you get over the time. So if you're working on the model and you're testing it, just to figure out how long you should run it, you will see some relation between how long you run it and how much improvement you get out of having it longer, having a longer run there. At one point, this will like shift between, or the benefit will not be there to wait longer for a better solution. So that's, for example, a point where you can say, okay, this might be the maximum amount of time I want to spend the solver, or I want to give the solver to solve the problem. And this is something that you want to figure out while working on the model, testing it, and iterate on the model formulations there.
Excellent. I'm going to slip in one more question that just came in from the audience, Daniel. What map providers do you support, or does Nextmove support?
So we have the option to use a custom matrix measure for the model. So you can use any map provider that you are familiar with or that you want to use for. What you have to do is you will create a custom matrix with travel times and maybe distances for the model, and you will put it into you can put it into the input file as well. To add to the model and consider it for travel time calculation and distance calculation. And we also have a small tutorial in our docs for that, where you can see how this is done, and also a template that shows you how you can implement such a custom matrix measure. But yeah, so this gives you a lot of flexibility in setting up your metrics, depending on what kind of provider you want to use there.
Excellent. Excellent. All right. I know that we are a few minutes over, and if you don't mind progressing to the next slide, Daniel, just a couple of shout outs for folks to be aware of. Everything you just saw Daniel walk through today, you are more than welcome to go and try this out for free. All you need to do is create a free account. After the Tech Talk here today, we'll be sending along the recording along with links to Daniel's demo code. So feel free to give this a whirl yourself. And if you have any questions along the way, don't hesitate to reach out to us. There's some really great resources. So we've got docs, blog posts, videos, more tech talks available on our website. And if you prefer to have those delivered to your inbox, don't hesitate to sign up for our newsletter, where we'll send you periodic updates. We do have more tech talks coming soon, so to keep an eye out for those by visiting nextmv.io, and you'll see more there. So with that, we're going to sign off. Thank you, Daniel. Thank you, everybody, for your questions and participation today. Until next time.
Bye.